So, this is the Leaving Cert Ordinary Level 2023, Paper 1, Question 4. The graph of the function g is shown in the coordinate diagram below for minus 3 less than or equal to x, which is less than or equal to 2. X is an element of R. That just means that x is going to be a rational number, so it can be a positive or a negative whole number. It can also be a fraction or a decimal. Okay, so it just means our x value will be between negative 3 and positive 2. Use your graph to answer parts A1 to A4. Okay, so you can see there the function g of x is given to us. It's a cubic function. We can see that it turns twice, so that would suggest it's a cubic, as opposed to a quadratic, which would be u-shaped or n-shaped, or a linear, which is just a straight line. So you can see there the first part of that question said use the graph to estimate the value of g of 1.5. Okay, and I've just wrote in here that g of x is equal to y. And what I mean by that is that g of x represents the function. The function gives you your input. The output is obviously your y. So it's saying estimate the value of g of 1.5. We put in 1.5 instead of x. So go to your x-axis, go to 1.5, and you can see that the corresponding y value will be 0. So g of 1.5 gives us an output of 0. Part 2. Estimate the value of x for which g of x is equal to minus 6. Okay, so in this case, we still don't know our input, but we do know our output. So our output is going to be when y is equal to negative 6. So go to your y-axis, come down as far as negative 6, come straight across until you hit the function, and we need to see what that corresponding x value is. So we know that when the y value is negative 6, that corresponds to an x value of minus 2.5. So minus 2.5 will be our x value. So that brings us on there to part 3. Part 3 says, tick one box to show how many real roots the function g of x has in this domain. Okay, give your answer, give a reason for your answer. So our options there are 0, 1, 2, or 3. If we were to go back up and look at the function, we can see that the function here only cuts the x-axis once. Okay, so it cuts the x-axis here. Anytime we've roots, it's when a function cuts the x-axis. So a function only cuts an x-axis at one point, so that means we only have one set of roots. So if we go back down here, we can say, we can tick 1 obviously, and we can say the function only cuts the x-axis once at minus 1.5 and 0. So that brings us on there to part 4. From the graph, estimate the coordinates of the local maximum point and the local minimum point of g of x as accurately as possible. Now, as I said earlier, we have a cubic function, and we know a cubic function turns at 2 points. So it turns up here and it turns down here. Those 2 points are represented by our maximum and our minimum. Okay, so maximum is always when it turns at the top, minimum is always where it turns at the bottom. We can see here that the maximum turning point is going to be negative 1.6 and negative 1, because it's negative 1.6 on our x-axis, negative 1 on our y. And our local minimum is going to be just here, which I've put down to be 0.25, 0.25, and negative 3.1. So it's just past 3, so negative 3.1. And that brings us on to part B. A different function, h of x, has the following equation. h of x is equal to x cubed plus 2x squared minus x minus 8. Find h dash of x, which is the first derivative of h of x. So write out the function of h of x, and then we need to be able to differentiate it by a rule. So if we're going to differentiate it by rule, the 3 comes down in front, so we end up with 3. The x stays where it is, and we reduce the power by 1, so it changes from 3 to 2. Plus 2. Now, the 2 is going to have to come down in front. It's going to be 2 times plus 2, which gives us 4. The x stays where it is. We reduce the power by 1, so instead of being 2, it's going to be 1. The negative 1x is going to turn into negative 1. And obviously the constant there is going to go away to nothing, so that's going to turn into nothing. And that brings us on there to part 2. So it said find the equation of the tangent to h of x at the point 2, 6. So we've got a function, we found the first derivative, and now they're asking us to find the equation of the tangent at the point 2, 6. So what we need to do here is we need to work out what the slope is. So we know that the rate of change is going to be represented by this function here. but we need to know what the rate of change is at a particular point. Now, we know the point is going to be 2, 6. We know the x value is going to be 2. So we need to see what the slope is when the x value is equal to 2. So we take the derivative, or the first derivative, which is the rate of change. We sub in the 2 instead of our x, and that will tell us the slope at that given point. So we're going to end up with a cubic. Obviously, a tangent only touches the cubic at one point. We can find the slope of it, by subbing in the value 2. If we were to simplify that, 2 squared is 4, 4 times 3 is 12, plus 4 times 2 is 8, take away 1. 12 plus 8 is 20, take away 1, leaves us with 19. So that tells us that the slope of the tangent is going to be equal to 19. Now, from that, we know that we've got a linear equation. So a tangent is obviously going to be a straight line. So a tangent is a straight line that cuts a curve at a point. So if we're dealing with a straight line, we need to use the formula for a straight line, which is y minus y1 is equal to m times x minus x1. We have our point, which we've labelled x1 and y1. We have our slope, which is equal to 19. So all we do is we take our equation of a line, we sub in our y1, our m, and our x1. So it'll be y minus y1, which in this case is 6, is equal to m, which in this case is 19, bracket x minus, and then we put in our x1, which is going to be 2. From there, all we need to do is we need to expand and simplify. Okay, so obviously the left hand side stays as y minus 6. Y minus 6 is equal to 19x, and we multiply the 19 here by the negative 2 to give us negative 38. Now, what we want to do is we want to give that in the form of x's, y's, and numbers. So I'm going to leave these 19x's here on the right hand side. I'm going to bring this y over to the right hand side, so it turns into a negative y, because it's moving across the equal sign. It's turning from a positive to a negative. The negative 38 is staying on the right hand side, and the negative 6 is coming across the equals again, so that's going to change from a negative to a positive. What we then need to do is we just need to tidy up these two numbers here. So we've got 0 is equal to 19x minus y. Negative 38 plus 6 gives us negative 32. And then we can just put it in the form of x's, y's, numbers. So we're just going to change these. So we write all of this on the left hand side, and we put equals to 0 on the right. And that's your final answer there for 2023 paper 1 question 4.